Hello everyone, myself Dr. Lakshmi Soujanya. I am working as an associate professor in the Department of Mathematics from Marri Reddy Institute of Technology and Management. In the previous sessions, we completed how to find the rank of a matrix using echelon and normal form. Also, we have done how to find the inverse of a matrix using Gauss-Jordan method. Today, we will see how to solve the system of equations. I think everyone know about the system of equations. Mostly you know about two equations with two unknowns like 2x plus 3y equal to some 4, x minus y equal to 2. You know these type of equations. So to solve these equations, we are having one procedure. By adding or subtracting those two equations, we are trying to eliminate one variable and we'll get the final answer for x and y. If it is three equations with three unknowns, in that case also you can solve the equations very easily. But in case of more number of equations with more number of unknowns, or m number of equations with n number of unknowns. That means the number of equations and the number of unknowns are unequal. In case of equality, we have one procedure. But in case of unequal cases, unequal equations with unequal number of equations and unequal number of variables, there we are not having any procedure to solve the system of equations. The only process we are having is matrix representation. In case of equal equations with equal number or unequal equations with unequal number of variables, we can go with matrix representation. Easily you can solve the equations using matrix notation. So here I am taking for example, I am taking m equations with n unknowns. Totally I am considering m equations 1 to up to m, and the number of unknowns are x1 to xn. So I am choosing m equations with n unknowns. So unequal equations, m and n both are unequal or maybe equal also. In both the cases, we can go with the procedure. So in this case, to solve these equations, here we'll take one matrix notation, that is Ax is equal to b. So here matrix A is a coefficient matrix, x is an unknown vector, b is a constant vector. Coefficient matrix means you are having m equations. You have to collect all the coefficients from the m equations in your matrix A. So here I am taking matrix A as, first you take first row is chosen coefficients from first equation. Your first equation coefficients are A11, A12 up to A1n. So you take those coefficients as the first row, A11, A12 and so on A1n. Similarly, second equation coefficients A21, A22 and so on up to A2n. So your second row is A21, A22 and so on A2n. Like that, if you are taking mth equation, the last equation, the coefficients are am1, am2 and so on amn. So this one is called as a coefficient matrix. Into x. What is x? X is a unknown vector. So you take a column vector with all unknowns. What are the unknowns here? x1, x2 up to xn are unknowns. x1, x2 so on xn. Next, capital B is a constant vector. Here the constants are your right hand side values. Those are b1, b2 and so on bn. So by choosing this matrix and vectors, we are representing the set of equations in the form of Ax equal to b. Now cross verify this case. A into x means you have to multiply these two matrices, A matrix and column vector x. Now see, row into column value, that is A11 into x1 plus A12 into x2 plus so on A1n into xn is equal to b1, your first equation. Similarly, if you are taking second row into first column, A21 into x1 plus A22 into x2 plus so on A2n into xn is equal to b2, your second equation. Like that, last one, am1 x1 plus am2 x2 plus so on amn xn is equal to bn. So it satisfies the condition of set of equations. So whether you have equal number of equations with that many number of unknowns or different number of unknowns, you can represent those set of equations in the matrix notation as Ax is equal to b. What is A here? A is a coefficient matrix, x is an unknown vector, b is a constant vector. So in this matrix notation, sometimes all these right hand side values are may be equal or sometimes may not be equal. That means in the matrix representation, Ax is equal to b. If this constant vector B is equal to 0, then we can call the type of system as homogeneous system. If it is non-zero, if B is not equal to 0, then the system is non-homogeneous system. We have two procedures to solve the system of equations. One is for homogeneous, second one is for non-homogeneous. So when we can say the system is homogeneous, if the capital B value is equal to 0. Non-homogeneous means capital B value, constant vector capital B is must and should be non-zero, not equal to 0. Here you have to know another terminology also, consistency and inconsistency. Consistency means when you are solving the system of equations, in case of equal number of equations with equal number of variables, definitely you will get the solution. But in some cases, whenever you are having unequal number of equations with different number of variables, in such cases you won't, sometimes there is a possibility of getting no solution also. So if the system has a solution, then the system is called as consistent. If there is no solution for the system, then such system is called as inconsistent. In case of homogeneous, definitely the system is consistent. You will get the solution. But for non-homogeneous, there is a possibility of getting inconsistency also. That means for non-homogeneous system, for some of the equations may not have the solution. So consistency means system has a solution. Inconsistency means the given system has no solution. So these are the basic terminologies you have to know about when you are doing the problems on system of equations. So you have to know what is homogeneous, what is non-homogeneous, what is consistency, what is inconsistency. Homogeneous means if all the constant vector, if each and every element in the constant vector is 0, then the system is homogeneous. If it is non-zero, system is non-homogeneous. Consistency means the system has a solution. Inconsistency means system has no solution. Now, first we'll see how to solve the homogeneous system of equations. Then we'll go to non-homogeneous system of equations. So here homogeneous system of equations means in Ax equal to B, B is must and should be equal to 0. Your right hand side value must and should be 0. So in this notation, you have matrix A, a constant matrix, and the unknown vector x. So what are the possibilities we can choose here for A matrix? Till now we calculated the rank only. We can take rank of matrix A. By using echelon or normal form, you can go with rank of A. And here in X, you are having some type of unknown vectors. So here we can take some number of unknowns. From matrix A, I am choosing rank. From vector X, I am taking number of unknowns. Now, by comparing these two only, we are giving whether the system has a unique solution or infinite solution. So, if both the ranks, rank of A is equal to number of unknowns, then we can say that the system has a trivial solution or zero solution or null solution. So, when it has trivial solution, if rank of A is equal to number of unknowns. If this rank value is less than the number of unknowns, then the system has infinite number of solutions. How we can calculate these solutions, that I will explain when we are doing the when we are solving the problems. So in case of equal solution, trivial solution means rank of A must and should be equal to number of unknowns. Unequal solution means rank of A. Infinite number of solutions means rank of A is must and should be less than the number of unknowns. Just remember these 2 points for finding the solution. So let us see one problem on homogeneous system. Here they have given we have to solve this homogeneous system equations, that is 2x minus y plus 3z equal to 0, 3x plus 2y plus z equal to 0, x minus 4y plus 5z equal to 0. So first write down the given system of equations. So the given system of equations are, first equation is 2x minus y plus 3z equal to 0. Second equation is 3x plus 2y plus z equal to 0. Next third equation is x minus 4y plus 5z equal to 0. So what is the first step for solving the homogeneous system of equations? Your step 1 is you have to know the matrix representation Ax equal to B. Here you have to identify what is A, what is X and what is B. Next, step 2, you have to calculate the rank of A. In step 3, you have to compare the rank of A with the number of unknowns. Basing on the relation, whether it is equal to or less than, basing on that relation, you have to give the conclusion. So, we'll done the problem in 3 steps. In step 1, you have to represent the given system of equations in matrix representation. In step 2, you have to take the rank, you have to calculate the rank for matrix A. And next, in step 3, you have to compare the rank value with the number of unknowns. In case of equality, you will get trivial solution. In case of less than, you will get infinite number of solutions. So, first do the first step, take the matrix notation. The matrix notation is Ax is equal to B. What is A here? Where A is equal to, you have to, A is a coefficient matrix. You have to collect the coefficients from each and every equation as a row. So, if you are taking first equation, what are the coefficients in the first equation? 2, -1, 3. So, your first row is 2, -1, 3. Next, coefficients in the second equation are 3, 2 and here 1. So, the coefficients are 3, 2, 1. Next, the coefficients in the third equation are 1, -4, 5. With the sign, I am taking the coefficients 1, -4, 5. Next, capital X. What is capital X? Capital X is an unknown vector. What are the unknowns here? X, Y, Z are your unknowns in all the 3 equations. So, capital X is X, Y, Z. Next, capital B is a constant vector. Here, all your right hand side values are 0, 0, 0. Since it is 0, I am going with the procedure of homogeneous system. So, what is step 2 in homogeneous system? You have to take rank for the given matrix. So, rank of A. For taking the rank of A, we are having 2 methods. Either you can go with echelon form or you can go with normal form. Since half of the solution in normal form is echelon form only, I will prefer echelon form. So, you convert this matrix to upper triangular form. For echelon form, you have to convert the matrix to upper triangular form. So, that means first you convert all the lower diagonal values to 0. So, in the first step, I'll focus on the values which are in the first column. That means you have to change R to R3. The non-changing row is R1. By using R1 only, you can change R to R3. So, the corresponding value in R1 is 2 and here I have 3. There is no common multiple. So, do the cross multiplication. That is, the row operation is 2R2 minus 3R1. Next, for R3, here I have 1, here I have 2. So, if you are getting 2 in R3, then 2 minus 2 you will get 0. That means you have to multiply the third row with 2. So, that is 2R3 minus R1. Then what about your matrix? We are not changing first row, 2 minus 1, 3. And second row operation is 2R2 minus 3R1. So, first multiply 2R2, multiply the second row with 2. 2 3s are 6, 2 2s are 4, 2 1s are 2. Next, 3R1, multiply the first row with 3. 3 2s are 6, minus 3, 3 3s are 9. By subtracting, this is 0. 4 minus of minus 3 plus 3, so that is 7. 2 minus 9 is again minus 7. Next, 2R3. Now, multiply the third row with 2, that is 2 minus 8, 2 5s are 10. R1 is 2 minus 1, 3. By subtracting, this is 0. Minus 8 minus of minus 1 plus 1. So, minus 8 plus 1 is minus 7. 10 minus 3 is 7. So, again, I'll represent the lower diagonal. Still, we are having one more value. You have to convert minus 7 to 0. That means which row we have to change here? We have to change R3. And the similar row for R3 is R2 only. The corresponding value in R2 is 7. Both are same values with opposite sign. So, by adding both the rows, definitely you will get R3 value as 0. That means row operation is R3 gives rise to R3 plus R2. So, we are not changing first 2 rows. The first 2 rows are 2 minus 1, 3, 0, 7, minus 7. Now, you have to change R3 as R3 plus R2. Just add these 2 rows. Then this is 0, 7 minus 7, 0, minus 7 plus 7 is again 0. So, we got upper triangular matrix. Then, what is rank of A? Rank of A is equal to, we have to convert the matrix to echelon form. So here echelon form, we have to convert to what are conditions we are having in echelon form. The number of zeros in first row, first non-zero row is must and should be less than the number of such zeros in the next row. Here I have 1 0, here I have 3 zeros. So it's satisfying the condition. Next, if there is any zero row, the zero row must and should be at the bottom of the matrix. Here zero row I have in the third row only, bottom of the matrix only. And the third condition, either you can do the third condition or we can skip the third condition also. Why? Because even though you will get the same rank value, your third condition is the first non-zero entry in each and every row is 1. So here we can skip, I am skipping that one, or else you can do that one also. If you are doing that one also, you can skip the third step also, but I'll do that one. So the third step is you have to divide the first non-zero value in a non-zero row must and should be 1. Here I have 2, here I have 7. So you divide the first row with 2, then R1 gives rise to R1 by 2. Similarly, second row is R2 gives rise to R2 by 7. Then we'll get the matrix as 1, minus 1 by 2, 3 by 2, 0, 1, minus 1, 0, 0, 0. Now it is totally satisfying the three conditions of echelon form. So if you are taking rank value, rank of A is equal to the number of non-zero rows in the echelon form. So how many non-zero rows you have here? I have only 2 non-zero rows. So rank of A is equal to 2. So with this, your step 2 is also completed. Now in step 3, you have to compare this rank value with the number of unknowns. Before going to that, see, if you are taking this one as echelon form, in this case also you have only 2 non-zero rows. Your rank is 2 only. Or else if you are taking this one as echelon form, here also you will get 2 rank as 2. That's why either you can do this step or else you can skip the third step, third point. So now I'll go to step 3. In step 3, you have to compare the rank value with the number of unknowns. How many unknowns we have here? The unknowns are X, Y, Z. Totally I have 3 unknowns. Now what is the relation we are getting? Rank is 2, which is less than the number of unknowns. So since the rank is less than the number of unknowns, the given system has infinite number of solutions. So if it has infinite number of solutions, means you have to know how to calculate that infinite number of solutions. To calculate that infinite number of solutions, again I'll go with the matrix representation. So here your matrix representation is Ax is equal to B. Now instead of taking the capital A value, instead of taking this capital A value, now I'll choose the matrix which you converted to echelon form. So instead of choosing this capital A here, I'll take this echelon form in Ax equal to B. So what is A? A is 1, minus 1 by 2, 3 by 2, 0, 1, minus 1, 0, 0, 0 into capital X is X, Y, Z equal to capital B is 0, 0, 0. So here you have to remember one point. In Ax equal to B, instead of taking the initial matrix, coefficient matrix A, you have to choose the matrix which you converted to echelon form. Then only you will get the solution. So now I'll take again, I'll represent the equation form. Take row into column form. So 1 into X plus minus 1 by 2 into Y, that is minus Y by 2, plus 3 by 2 into Z equal to, the first value is 0 here. Next second equation, 0 into X plus Y minus Z equal to 0. See, actually I have 3 unknowns, but here on simplification I got only 2 equations. I have 3 unknowns and 2 equations. How many number of equations we are getting, we are losing here? 1 equation. So you have to choose one arbitrary constant for one variable. Basing on number of equations missing at this step, you have to choose that many number of variables as arbitrary constants. Since I have 2 equations with 3 unknowns, one equation is reducing here, one equation is losing here. So for that you have to take for one variable you have to choose arbitrary constant. Out of x, y, z, you can choose any variable. Since in the second equation clearly I have only two variables, so if I choose arbitrary constant for any one of the variable here, easily I can solve the equations. So either for y or z you can take the arbitrary constant. Here I will choose arbitrary constant for z. So now what we have to do, we have to take arbitrary constant for one variable. I'll taking that constant for z. So if you are taking the z value in equation 2, then you will get y minus z is k equal to 0. That means y is equal to k. Now take both z and k in equation 1. Then this is x minus y is k by 2 plus 3 by 2. Z is again k equal to 0. So minus 1 by 2 plus 3 by 2 is 2 by 2. 2 are cancelled. You will get x plus k equal to 0. That means x is equal to minus k. So now what is the solution? Capital X is x, y, z. That is x is minus k, y is k, z is k. By taking k is common, you will get minus 1, 1. This is the solution for the given system of equations. Again, I am repeating the procedure. See, total procedure we have done using problem only. Only the introduction part is for identification of homogeneous and non-homogeneous. How we can identify homogeneous system? If the matrix vector B value equal to 0, then the system is homogeneous. See, here B equal to 0. That's why this system is homogeneous. So what is the procedure we are following to solve the homogeneous system? We are doing two steps. In the first three steps, we are doing three steps. In the first step, you have to take the matrix notation for the given system of equations, identify the values of A, X and B. In second step, if it is homogeneous, you have to take the rank of matrix A. In third step, you have to compare the rank value with the number of unknowns. If it is equal, you will get unique solution. Directly you will get the solution. In case of less than, you will get infinite number of solutions. Those infinite number of solutions are calculated by using the relation Ax equal to B. But here you have to remember one thing. Instead of taking in this step, at this step, instead of choosing the coefficient matrix, initial coefficient matrix A, you have to take the matrix which you converted to echelon form. Then here I taken matrix which I converted to echelon form. I taken x value, b value. Now again rewrite the equations for this matrix representation. Multiply the matrices, you will get set of equations. But always here you will get less number of equations with the number of unknowns. If you have 3 number of unknowns, you may get 1 equation or 2 equations depending on the situation. So since how many number of equations we are losing at this step, for that many variables you have to choose the arbitrary constant, then only you will get the infinite number of solutions. How it is infinite? See, in this case I have 3 unknowns, but I got only 2 equations. That's why I have chosen arbitrary constant for one variable and I substituted that arbitrary constant in the remaining 2 equations. Then I got the values of x, y, z. But when k is varying, your solution is also varying. If k is 1, you will get one solution. If k is 2, you will get another solution. So basing on the k value, here you are getting infinite number of solutions. So is it clear? Now see another problem on homogeneous system. So here I am taking another question. Solve the homogeneous system 3x plus 4y minus z minus 6w equal to 0. So that means here I have chosen 4 variables with 1, 2, 3, 4 equations. 4 variables with 4 equations. So first write down the equations. The given equations are, your first equation is 3x plus 4y minus z minus 6w equal to 0. Second one, 2x plus 3y plus 2z minus 3w equal to 0. Next, 2x plus y minus 14z minus 9w equal to 0. Next, x plus 3y plus 13z plus 3w equal to 0. So what type of equation it is? First you write down the matrix notation, then you will get the type of equation, whether it is homogeneous or non-homogeneous. So the matrix notation is Ax equal to B, or else by seeing right hand side value only you can take the type of equation. But better to go with this procedure. You take matrix notation, basing on B value, identify the type of equations. So what is A? A is a coefficient matrix. So the coefficients in the first equation are 3, 4, minus 1, minus 6. Next, the coefficients for the second equation are 2, 3, 2, minus 3. For the third equation, 2, 1, minus 14, minus 9. Next, for the fourth equation, the coefficients are 1, 3, 13, 3. Next, capital X. Unknown vectors. What are the unknown values we are having here? X, Y, Z, W. So, X, Y, Z, W. Next, capital B is a constant vector. Here all the right hand side values are 0. So, capital B is 0. Now, since B equal to 0, this system is a homogeneous system. So, what we have to do in step 2 for homogeneous system, you have to calculate the rank of the matrix A, coefficient matrix A. So, for taking the rank of this matrix A, first you have to convert this to upper triangular form. So, here upper triangular form means you have to convert all these lower diagonal values to 0. So, what are the row operations? First step, you focus on the values which are in the first column. That means you have to change R2, R3, R4. How we can change these values? Here I have 2. By using R1 only, we can change R2, R3 and R4. In R1, the corresponding value is 3. There is no common multiple. So, do the cross multiplication. That is 3R2 minus 2R1. Similarly, for R2 also here I have 2. So, same 3R3 minus 2R1. Next, here I have 1 in R4. So, if you are multiplying 4th row with 3 and subtracting with R1, you will get 0. That means 3R4 minus R1. Now, what about the matrix? The first row is 3, 4, minus 1, minus 6. Here I am doing the rough part. First R2 is changed by 3R2 minus 2R1. So, multiply the second row with 3. 3 2s are 6, 3 3s are 9, 3 2s are 6, minus 3 3s are 9. Next 2R1, multiply the first row with 2. 2 3s are 6, 2 4s are 8, minus 1 into 2, 2 6 are 12. Now, by subtracting, you will get 0. 9 minus 8 is 1. 6 minus of minus 2 plus 2, so that is 8. Minus 9, minus of minus 12 is plus 12. So, minus 9 plus 12 is 3. Next, R3 we are changing as 3R3 minus 2R1. So, multiply the third row with 3. 6, 3, 3 14s are 42. Next, 3 9s are 27. So, this is minus 27. And multiply the first row with 2. 6, 8, minus 2, minus 12. Now, by subtracting, this is 0. 3 minus 8 is minus 5. Minus 42, minus of minus 2 is plus 2. So, minus 42 plus 2 is minus 40. Next, minus 27, minus of minus 12 plus 12. Minus 27 plus 12 means that is minus 15. Next, R4 is changed as 3R4 minus R1. Now, multiply the third row, fourth row with 3. 3 1s are 3, 3 3s are 9, 3 13s are 39, again 3 3s are 9. R1 is 3, 4, minus 1, minus 6. Now, by subtracting, this is 3 minus 3 0, 9 minus 4 is 5, 39 minus of minus 1 plus 1, so that is 40, 9 minus of minus 6 plus 6, 9 plus 6 is 50. Now, we again represent the lower diagonal values. These are your lower diagonal values. So, we converted all the first column values to 0. Now, you convert all the second column values to 0. That means, what are the row operations? You have to change R3 and R4. The similar row for R3, R4 is R2 only, and the corresponding value in R2 is 1. So, here if you have 5, by adding and subtracting, you will get 0. That means, for R3, the row operation is R3 plus 5R2. For R4, the row operation is R4 minus 5R2. Then you will get, we are not changing first two rows, that is 3, 4, minus 1, minus 6, 0, 1, 8, 3. Now, if you are multiplying the second row with 5, you will get 0, 5, 40, 15. Now, compare R3 and R4. In R3 also I have 5, 40, 15 with opposite signs. So by adding, you will get R3 as a 0 row. Next, in R4 also, I have 5, 40, 15, same values. So by subtracting, you will get R4 as a 0 row. Now, we converted all the lower diagonal values to 0. All are converted to 0. Now see, here I am skipping the second step. Why I am skipping the third step means in echelon form we are having 3 points. If there is any 0 row, it has to be bottom of the matrix. I have 2 0 rows. 2 0 rows are at bottom of the matrix. Next, the number of zeros before the first non-zero value is less than number of such zeros in the next row. Here I have 1 0, here I have 2 zeros, here I have 3 zeros. It is clearly satisfying that condition. If you skip the third condition, the further calculation becomes easy. That's why I'll skip the third condition. In both the cases, you will get same rank value. So there is no variation in the rank. That's why I'm skipping the third condition. So now what is our rank? Rank is equal to the number of non-zero rows in the echelon form. So how many non-zero rows I have here? 1, 2. So your rank equal to 2. Next, in the third step, you have to compare this rank value with the number of unknowns. How many unknowns I have in this question? X, Y, Z, W. Totally I have 4 unknowns. So number of unknowns are 4. Now what is the relation we are getting between rank and number of unknowns? Clearly rank is less than the number of unknowns. So it is less than the number of unknowns means how many solutions we are having here? If it is less than, you will get infinite number of solutions. The system has infinite number of solutions. So now how you can find those infinite number of solutions? What we have to do here? Again, you have to take the matrix representation Ax is equal to B. Now which one we have to choose here? Instead of taking the initial coefficient matrix A, you have to choose the matrix which you converted to echelon form. So your matrix is 3, 4, minus 1, minus 6, 0, 1, 8, 3, 0, 0, 0, 0, 0, 0, 0, 0 into X is X, Y, Z, W is equal to B is 0, 0, 0, 0. So now write down the equation form. You multiply both the matrices and write the equations. So how many equations we got here? First equation is 3 into X plus 4 into Y minus 1 into Z minus 6 into W equal to 0. Second equation 0 into X 0 plus 1 into Y plus 8 into Z plus 3 into W equal to 0. Remaining 2 rows are 0 rows. So into X, Y, Z means you will get 0 only. So here for 4 variables, I got only 2 equations. That means for how many variables you have to choose arbitrary constants? For 2 variables you have to choose arbitrary constants. Since 2 equations are missing here, 2 equations are losing here. So we have to take arbitrary constant for 2 variables. Again in the similar way, in the second equation I have 3 variables. So for these 3 variables, out of these 3 variables, you choose any 2 variables as arbitrary constants. I'll prefer Z and W. Then you will get further calculation, you will get very easily. So that means here you have to take Z is equal to some K1 and W equal to K2. Now substitute these two values in equation 2. Then Y is Y plus 8, Z is K1 plus 3, W is K2 equal to 0. That means Y is equal to minus 8K1 minus 3K2. Now take X, Y, Z, Y, Z, W values in first equation. Then this is 3X plus 4 into Y is minus 8K1 minus 3K2 minus Z is K1 minus 6 into W is K2 equal to 0. So now what about this one? This is 3X. 4 8s are 32. So minus 32 K1 minus K1 means minus 33 K1. Next 4 3s are 12. Minus 12 minus 6 means minus 18 K2 equal to 0. Now take these two values to right hand side and divide the total equation with 3. Then you will get X as plus 11X1 plus 6K2. So now what is the solution? Your solution capital X is X, Y, Z, W. That is X is 11K1 plus 6K2. Y is minus 8K1 minus 3K2. Z is K1. W is K2. So on simplifying, on separating K1, K2, basing on K1, K2 values, you will get infinite number of solutions. So like this, we can find the solution for homogeneous system of equations. We followed 3 steps. First, we are taking matrix representation for the given equations. In step 2, we are taking rank of the matrix. Step 3, we compare the rank with the number of unknowns. See, in case of equal, here I have chosen 2 problems. In both the problems, I got different ranks. Rank is less than the number of unknowns. For suppose, for the given equation, if possible. So for suppose in the matrix, final matrix, we got one matrix A, X, B. They have given some A, X, B. X with 3 unknowns, X, Y, Z. They have given some X, Y, Z. B is a constant vector 0, 0. We have some coefficient matrix also. Sometimes when you are converting this A matrix to upper triangular form, you may get like 1, 2, 3, 0, 2, 3, 0, 0, 3. It is also an upper triangular form. It is also satisfying that condition. So in such cases, when you are getting matrix in this form, here if you are taking matrix representation Ax equal to B form, you will get A matrix as 1, 2, 3, 0, 2, 2, 0, 0, 3, and X is X, Y, Z equal to B is 0, 0, 0. Now see, if you are comparing the rank and the number of unknowns, here rank is equal to number of non-zero rows are 3 and number of unknowns are also 3. Both are equal. So if these two are equal, then the system has a trivial solution. Trivial or null or zero solution. So how we can find the trivial solution? We can take matrix representation. We can substitute those matrices here. Now write down the equations. Your equations are x plus 2y plus 3z equal to 0, 2y plus 3z equal to 0, 3z equal to 0. Now see, from this equation clearly we got z as 0. If you are taking z equal to 0 in the equation, you will get y as 0. By taking both y and z equal to 0 in this equation, you will get x as 0. So that means your trivial solution is x, y, z, that is x, 0, 0, 0. So like that, in both the cases, if rank of A is less than number of unknowns, we have to follow the previous problems. By taking one arbitrary constant or 2 arbitrary constants depending on the missing number of equations, you will get the infinite number of solutions. In case of equal ranks, if both the rank and the number of unknowns are equal, in such cases, by taking the equation form directly, you will get the values as x, y, z as 0 by substitution only. So is it clear how we can follow the homogeneous system of equations? So in the next session, we'll discuss how to solve the non-homogeneous system of equations. Thank you.